Now we're going to look at what's called a main diagonal. And a main diagonal is a matrix, and we're just going to look to the left of the augmented matrix. We are looking for the part of the matrix that makes a diagonal starting in the uppermost left-hand corner. The other important information about the main diagonal is that all the numbers that are under the ones, so notice we have our line of ones right here, all of the numbers that make the diagonal line, the numbers underneath it must be 0. So these three numbers must be 0. But if there are more, like if there were 4 rows or 5 rows, the numbers all under the numbers of 1 must be 0. The numbers above the diagonal can be any number. So notice that I put A through F to designate numbers that could be positive or negative. So this is our main diagonal. The purpose of the main diagonal is to look at what's called Gaussian elimination. Now we've looked at elimination with system of equations, but now we're going to look at using the calculator and Gaussian elimination to solve problems that have 3 or more variables. We can also do it with 2 variables, and we'll look at an example like that in a second. So what this is going to look like is if I get this for an answer, and I know that it's got a main diagonal of 1, we can see that right here, and it's got zeros underneath the 1, so this is a main diagonal. We always are going to have to draw this in. Your calculator will not draw in the augmented line. Then we can read across. For this problem below, we see that we have x plus 4y plus 6z equals 9. Likewise, on the second line, notice that we have no x variable because it's 0. So now we just have y plus 2z equals 3. And lastly, we have z equals negative 1. Well, now we can solve this set of equations. We already know that z equals negative 1. Using this one, going to the second line, we now see that y plus 2 times negative 1 equals 3 can be solved. So we have y plus negative 2 equals 3. So we have y equals 5 as an answer. Fix that. We have y equals 5. And now we have y and z, so we can use the top equation and have x plus 4 times 5 plus 6 times negative 1 equals 9. So we have x equals, we have 20, 4 times 5 is 20, 6 times negative 1 is negative 6, so that's x plus 14 equals 9. And we get x equals, so subtract 14, we get negative 5. So this is how we would solve a Gaussian elimination once it's in the correct format. So now let's figure out how to do a Gaussian elimination problem. To do this, we're going to backtrack on how to solve system of equations. So this is my system of equations. Notice I have 2 equations, 2 variables. So when we looked at elimination, we looked at doing different things, but there are a couple questions you need to think about before we can start doing this. The first question is, can I switch equation 1 with equation 2? And the answer is absolutely. I can switch the top equation for the bottom equation, and it's still the same thing. I'm still going to get the same answers. The only thing is, now my equation that was on the top is now on the bottom. So we can switch equations. Notice I didn't change pieces of the equation. I switched the entire equation. The top equation is now on the bottom, and the bottom is now on the top. Looking at the same problem, now I want to think about solving it. Can I multiply each row by a different number? Well, if I want to solve this by elimination, I would want to have either the x's that are the same or the y's that are the same. So yes, I can multiply each equation by a different number. So if I multiply the top equation by negative 3 and the bottom equation by 2, let's see what happens. Now I get negative 6x plus 21y equals negative 6. On the bottom, I get 6x plus 2y equals negative 40. And then we could continue on. These equations are still the exact same equations as above, they've just been multiplied by a different number. So now we know that we can also multiply entire equations by different numbers. So using what we know, if we go to this one, we're going to solve it by elimination, which is what we learned how to do when we solved system of equations by elimination, substitution, and graphing. So if I were to do this, we're going to do it step by step to refresh you. We're going to have negative 3, and on the bottom one we're going to multiply by 2. Remember, the purpose is that we want to eliminate one of the variables, so one of them must be negative. It doesn't matter which. I could have done positive 3 and negative 2. But this is what I chose. So again, we have negative 6x plus 21y equals negative 6, and 6x plus 2y equals negative 40. So now we're simply going to go ahead and add going down. When I add these together, my x's are going to cancel. Add going down and I get 23y equals negative 46. I'm going to divide by 23 and I get y equals negative 2. So now I know what y is. So let's refresh what we did. We multiplied by two things and then added our equations together. So I'm basically adding line 1 to line 2. Please remember this because we're going to use this in just a second. Of course, now we have to solve for x. So using either equation, I'm going to choose the top one. We now have substitution using what y is, which is negative 2. So we have 2x plus 14 equals 2. We get 2x. We're going to subtract 14, so we get negative 12. And x would equal negative 6. Now remember, if we wanted to do this correctly, we would go back and check, and we'd have 2 times negative 6, which is negative 12, plus 14, which gives me positive 2, and 3 times negative 6, which is negative 18, plus negative 2 gives me negative 20. So this is the correct answer. Now we're going to learn to do this using Gaussian elimination. So remember that we have changed the numbers, and remember that we can also multiply by different things and add functions together. So before we get started, I'm going to put a model of what we want it to look like when it's finished. It's going to look like this when we're finished. Actually, this is going to be an A, B, and a C. Okay? So again, remember, this is our diagonal line, or our main diagonal. The numbers under it are 0, and the numbers above it can be anything. And of course, we want those answers to be numbers. So the first thing we want, if we look at this, and we want our main diagonal to look like this, is we should probably write this as an augmented matrices. So we have 2, negative 7, line 2, and 3, 1, negative 20. Now I'm going to go step by step. The first thing we want to do is we want to get 1 in this location. So if I could switch an equation, then I would. But 3 isn't going to work for me because 3, I'm still going to have to do something with it. So now I want to figure out what I need to multiply this row by to make this value equal 1. So if I multiply this entire row by a half, then it should change this 2 to a 1. So now we're going to do that in this step. So we're not changing anything on the bottom, so I'm going to leave that the same. And what we're going to do is multiply the entire top row by a half. Remember, we did this in the last one, so it's not that big of a deal. 2 times a half is 1. 2 times negative 7 is negative 7 halves. If you're more comfortable with fractions, that's fine. If you're more comfortable with decimals, that's fine. 2 times a half is 1. Great. So far, it looks like everything is on track. Notice that I have my diagonal. The only problem that's wrong with my diagonal is this number, and I'm going to put it in a different color, and that's this number. And this number has to be, according to this one, it has to be a 0. So this is where we're going to look at multiplying and adding the lines together. So I'm going to look at the top equation, and I see that I have a 1 right above it. I want this to be -3, and then I'm going to add it to the bottom equation. So for this line, or for row 2, I'm going to multiply -3 times row 1, and that's the row above it, plus row 2, which is this row. So we have row 1 and row 2. Remember, these are columns going down, but they're rows going across. So I'm going to do this step underneath. So we have 1 -7/2 and 1. And now we're going to do the step that I said. And remember, we're trying to get this to be 0. So we're going to take the row above it and multiply by -3. So I have -3 times 1. -3 times -7/2. -3 times 1. So I've multiplied the top row, and now I'm going to add it to the second row. Remember, the entire purpose of this, hold on, I've made a mistake. I'm adding it to the row. So we should have 3, because that's what we have, then 1, so plus 1, then -20, or plus -20, if you'd rather write it that way. Now we can simplify this again. We have 1 -7/2 and 1. So now let's simplify our bottom line. -3 times 1 is -3, plus 3 is 0. On this one, now we have 21 divided by 2 plus 2 over 2. So that is 23 divided by 2. So we have 23 divided by 2. And we also have -3 times 1 plus -20, which is -23. Now, we already had that one diagonal, but look, now we've messed it up. But that's okay, because we have the 1 and we have the 0. So now the only thing left is that we must fix this. And we want to multiply this row. Row 2 is going to be multiplied by 2 divided by 23. So when I do that, that's going to give me, we're going to write this one right here, 1 -7/2 and 1. And then we have 0 times 2 23rds. And the reason we're using 2 23rds is because when I multiply by 23 over 2, I get 1. So 0 times any number is 0. Then we're going to multiply by its opposite. So 23 over 2 and 2 over 23 gives me 1. Great, look, we have the diagonal and we have 0, so we have a main diagonal now. And -23 over times 2 divided by 23 is going to cancel the 23's, and I'm left with -2. So now we just simply need to solve. So I'm going to put this on the next slide. So we're going to solve now. So we have x plus -7/2 y equals 1, and y equals -2. Well, great, we know what -2 is. That's perfect. So now we're just going to do x plus -7/2 times -2 equals equals 1. So we have x -7/2 times -2. My 2's cancel, and I'm left with +7 equals 1. Subtract 7, and we get x equals -6. If you remember back 2 slides ago, that's exactly what we had when we solved by elimination, which is great. So this is the process for Gaussian elimination.